This is a MILWAUKEE M18 12mAh high output lithium-ion battery pack. It is about just over 4 years old. I use this battery pack with my MILWAUKEE power tools for my DIY projects. Just recently, this battery pack started showing charge status problems. So if I push on the battery status indicator here, you see that there are 3 LEDs lit up instead of the full 4. And if I insert the battery pack into this MILWAUKEE battery charger, you'll notice that the LED charge status light shows green, indicating that it thinks the battery is fully charged and therefore doesn't need further charging. This battery pack has a 5S3P battery configuration, and essentially the 5 banks of lithium-ion cells are out of balance. Join me in this video as I open up this battery pack and use this ToolKitRC M6DAC balance charger with this 5S balance cable that I made to restore the 5 banks of cells in the battery pack. Working on lithium-ion battery packs can be dangerous as they can be flammable and explosive if wrongly handled or damaged. So I have put a fire blanket underneath the equipment, and I have another fire blanket on the ready. I also have a fire extinguisher on hand and will be wearing safety glasses. This MILWAUKEE M18 12mAh high output lithium-ion battery pack is about just over 4 years old. The battery pack is built from 5S3P battery cells, so that's 5 in series, 3 parallel. The 5 in series battery cells are out of balance in their voltages, and so if I press on this battery status button, it shows 3 LED lights instead of 4. That indicates it is not fully charged. However, if I insert this battery pack into this MILWAUKEE M12-18C3 charger, it shows a green LED status light, which will indicate that as far as the charger is concerned, this battery pack is fully charged and does not need further charging. So this battery pack does have a problem. I have a FLIR CM82 clamp meter. I've set it to measure DC voltage. I will use the clamp meter to measure the voltage of the battery pack. The probes of the clamp meter are too thick to reach the electrical contacts, so I'll use these insulated blade terminals to push them in there. There's a symbol of the polarity on the battery pack. That is positive on the left and that is negative on the right. Insert the probes, and the multimeter says 19.46 volts. Opening up the lithium-ion battery pack is risky, as damaging it or mishandling it can result in an explosion and a fire. So whilst I'm doing this for myself on my own equipment, I do not recommend anyone else doing this unless you are a qualified service technician or an electrical engineer. So if you open this up and manipulate it, you're doing so at your own risk. To separate the bottom case from the top cover, I will have to undo 1, 2, 3, 4 security Torx screws, and then to release the internal battery cells from the bottom of the case, I will have to remove 1, 2, 3, 4 Torx screws, but these are not security Torx. They are just the plain Torx screws. This is a set of security Torx screws. I need the size T10. I'll remove these 4 screws first. I have to be careful not to damage the heads. Have to be very careful not to damage the head. So there are 3 lengths of screw. The longer screw for the front, the medium length screw for the rear, and the shorter screw for the base. You saw how difficult it was for me to use the L-shaped Torx wrench key to remove the deep screws in the battery pack. So I later bought a set of chicane 8-piece Torx tamper-proof screwdriver set. It was so much easier and more stable to use on the M18 battery pack screws. Gently open the top cover. I've put electrical tape and labeled the 6 electrical contacts. This is the negative contact of the 5S 3P battery pack. This is the 1S, 2S, 3S, 4S, and the 5S. So to measure the voltage of the total battery pack, I will put a probe between these 2 contacts. Slowly remove the battery pack from the casing. Here we are. This M18 12mAh battery is a 5S 3P battery configuration. 3P means 3 cells in parallel. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I cannot see the label on the brand and model of each of the cells, but I think it could be a Samsung INR21700-40T lithium-ion cell. Each of those cells has a rated capacity of 4 mAh, so 1, 2, 3 of them in parallel will provide 12 mAh. Then because I have 1, 2, 3, 4, 5 of them in series, and each of the cell has a nominal voltage of 3.6 volts, then 5 of the cells in series provides a nominal voltage of 18 volts. That is how this pack provides 18 volts, 12 mAh. I've set the clamp meter to measure DC voltage. I believe there is a conformal insulation coating on all of the shiny electrical contact parts. So when I apply the probe, I will have to push down a little hard. First, voltage of the 1S, 3.76 volts. Voltage of cell 2, 3.97 volts. Voltage of cell 3, 3.83 volts. Voltage of cell 4, 4.12 volts. Voltage of cell 5, 3.65 volts. Now measure the total 5S 3P voltage. 19.47 volts. I will check that by measuring across these contacts. 19.46 volts. So the voltage difference between the lowest 3.65 volts to the highest 4.12 volts, that is a very significant voltage difference, and that is not good. What is interesting is when I add each of the 5 cell voltages together, gives me a total of 19.33 volts. There is about 0.13-0.14 volt difference between me measuring it at the end-to-end terminals here and here. I wonder why the difference. My guess is that the conformal coating on the electrical surface reduces the voltages measured by the clamp meter probes. But in any case, the major difference is that between the 5 cells, the voltage difference is too high. So when I push the battery status indicator, it shows 3 LED lights because it's not fully charged and it's not in balance. Whereas when I put this battery pack on the Milwaukee AC mains charger, it shows a green LED light thinking that it's fully charged and so doesn't charge it. So this battery pack will continue to be undercharged and will degrade over time because of the imbalance. And that is what I need to fix. I need to rebalance this battery pack. To restore balance to this MILWAUKEE M18 battery, I bought this ToolKitRC M6DAC dual smart charger. It has two channels for charging, channel 1, channel 2, an XT60 DC power output capable of 350 watts, a 6S balance port, and depending on the number of pins I use, I can charge from 2S up to 6S. Channel 2 consists of the same capabilities as channel 1, and in the center there is a temperature sensor port. These two channels can be used separately to charge two separate battery packs, or they can be configured to be synchronous, where the two XT60 outlets join into a 2-in-1 cable to provide a total of 700 watts. And in synchronous charging mode, it only needs one balance cable connected. This LCD display is a high quality IPS 3.5-inch 480 by 320 resolution. So that's channel 1, this is channel 2. To provide input power, I'm presently connected to a AC input socket which accepts AC 100 volts up to 240 volts input. And on this side, it has an XT60 socket which accepts DC input of 7 up to 28 volts, either from a external battery supply or from a AC to DC power supply. This is a Type-C USB connector. It provides firmware update when connected to a computer, and it also provides up to 65 watts charging output at 20 volts. This Type-C charging port accepts a large number of protocols, which include PD, QC, AFC, and many others. On this side, there is a cooling fan. When the internal temperature of the device exceeds 45 degrees Celsius, the fan turns on half-speed airflow to reduce noise. When the internal temperature exceeds 53 degrees Celsius, the fan turns on full-speed airflow to enhance heat dissipation. I will power up this balance charger again so you see the startup screen. Starts up very fast. To provide input to the device is very simple. There is a button here to change the channels. And it's also a exit or escape button to move up a menu. There's also a scroll wheel that I can scroll left or right, and also press as OK to accept an option. So I'm now in the menu to choose the profile for the battery I want to charge, and I'm presently on channel 1. If I scroll right, my first parameter, battery type, it's showing lithium ion. Press OK. I have a very wide selection: lithium polymer, lithium high voltage, lithium ion. I assume this includes lithium iron phosphate, lithium ion. LTO means lithium titanate, nickel metal hydride, lead acid battery. And in fact, I can choose to use the output as a power supply. If I press OK, I can opt to use this device as a constant voltage power supply. Press and I can choose the voltages I want from 1.0 up to 28.0 volts. I'll reduce the voltage. And say it is 12 volts. Scroll down to choose the maximum current ranging from 0.5 amps up to 15 amps. Let me scroll up to 2 amps. And so as a constant voltage power supply, it will provide 12 volts and up to 2 amps. Press exit. Press OK again. Scroll right. I don't want it to behave as a power supply, so I'll click OK. And the last option is UAV battery. So under UAV battery types, there are drone manufacturers with models of drones that this charger can cater to. If I click OK, you'll see there's Mavic Air 1, Mavic Air 2, Mavic 1, Mavic 2, Mavic 3, Phantom 3, Phantom 4, Inspire 1, 2, 3, FPV, Avatar. I'll press exit. And based on whatever drone it is, I can set the maximum charging current, 0.5 amps up to 15 amps. Press OK. I'll go back up to battery type, press OK, and choose the actual battery type for the MILWAUKEE M18 battery, which is lithium ion. Scroll down, click OK. This is the number of cells in series. You can do automatic detection. In automatic mode, the charger will automatically recognize the number of connected battery cells according to the battery voltage connected to the output port. I suspect this may not be accurate if the voltage is too low or the battery pack suffers badly from out of balance cells. What I want is 5S. Press OK. Scroll down to mode of operation, press OK. I have 3 modes. I can use this device to charge, I can use this device to discharge a battery, or I can use this device to provide storage charge to the battery. I'll scroll back up to charge and press OK. Scroll down to end voltage, press OK. And based on the type of battery chemistry I've already specified, the end voltage range is provided. Here it shows 3.95. And I'm restricted to 4.15 volts. I can't go higher than that, even though it shows the range is there. It must be an automatic maximum value for the lithium ion battery. In the technical specifications for the Samsung INR21700-40T battery, it states that standard charge should be 2 amps and 4.2 volts. So I will keep it to 4.15 volts since it doesn't have 4.2 volts. Press OK. Charging current, press OK. Again, the Samsung battery specifications state that standard charge for one cell should be 2 amps. There is a higher rated charge of 6 amps, but to be safe, I will only charge each cell at 2 amps. And since the battery pack is a 5S3P, 1, 2, 3P, that means 3 cells in parallel. This will take 2 amps, this will take 2 amps, and this will take 2 amps, so total of 6 amps. So I will change this setting of the maximum charge current to 6 amps. So to review, it is a lithium ion battery pack. It is 5S. I want to use charge mode, and the end charge voltage for each cell is 4.15 volts. And the charge current for the 3P cells in parallel is 6 amps. Go back up, exit. Because I'm powering up this device from the AC mains, it has a built-in transformer, and that built-in transformer is able to provide 200 watts output. However, if I was to disconnect this AC mains in and connect a DC power cable to the rear, and in turn connect this lugs to an external battery, I will be able to actually provide 350 watts channel 1 and 350 watts channel 2, or combined 700 watts across the 2 channels. So a higher charge output is possible when the device is powered by suitable DC input. And the reason is the built-in transformer is small, so it's limited in the output it can provide, and that's understandable. So this says the input power supply is 24.09 volts. It is using 0.0 watt-hours power since there's no output charging cables connected. The USB port at the rear is not connected, so it shows 0 volts, 0 amps. The internal temperature shows 38.4 degrees Celsius. And this is a symbol of the internal cooling fan. It is not spinning at the moment because the internal temperature is below 45 degrees Celsius. This is a 5S balance cable that I made. It uses a GST XH6S connector. These cables are of AWG 20 gauge, and I terminated each of these cables with insulated blade terminals. The color sequence of cables I use is black for ground, then a yellow, which I've marked with a black marker, then a blue, a green, another yellow, and finally red for the 5S. From a safety point of view, I need to connect these blade terminals first to these electrical contacts and then connect this plug into that balance socket. The black cable is ground. I will slip it into this. The first yellow cable that I've marked with a black marker as well on this side will slip into this. The third cable, which is blue, will go to the 2S position. The next cable is green, and this will go to the 3S contact. The next cable is second yellow. This will go to the 4S contact. The last cable is red, which will go to the 5S contact here. I need to be very careful not to insert the blade terminals into parts where it is too tight or too loose. I've seen other videos on YouTube where people doing rebalancing of the Milwaukee batteries have soldered bare wires to the contacts. I did not want that because, for one thing, it's scraping off the conformal insulation from the metal surfaces. Another thing, it is soldering, and so it's more time consuming and messy. And thirdly, to remove that wire, I have to desolder it, and that again can be messy, and furthermore it may leave some solder pieces on the contacts which eventually become loose and could fall into parts where they should not and short circuit the battery pack, causing a fire. So I preferred my approach of the blade terminals where I can slip them in, slip them out quickly without damaging the contacts. Now with all the blade contacts connected, I insert the JST connector with my ground cable towards the left. There is a symbol here for negative, so that goes in this way. I do not need to force it. The same DC powered cable that I made can also be used to connect to the terminals on the Milwaukee battery pack and to the XT socket outlet. This extreme left contact is positive. Push that in. That extreme right contact is negative. Push that in. Connect the XT60 plug into the channel 1 socket. Press OK. Check again the charging specifications, and if I scroll left and right, it moves between here and here. I'll press OK to start. It says channel 1 charged to 20.75 volts. Press OK. I get error message that channel 1 balance port high cell voltage. I will investigate what this means. I had to readjust some of the connectors to the contacts here because of the conformal coating. So now all the 6 contacts are good, and that's evident from the fact that in the reading here it shows cell 1 is 3.783 volts, cell 2 3.993 volts, cell 3 3.852 volts, cell 4 4.13 volt, cell 5 3.666 volts. So these values here, which I measure with my clamp meter, are similar to the values here shown in the charger. With everything now connected, I want to start charging. Press OK. Check all the settings are correct. Lithium ion, 5S battery, I want to charge. End voltage for one cell, 4.15 volts. Charge current for the 3P cells in parallel, 6 amps. Press OK. And the charger wants me to confirm channel 1 charged to 20.75 volts. And 20.75 volts is essentially 5 times 4.15 volts. So I press OK. It is now commenced charging. It says lithium ion 5S charging. It shows 1, 2, 3, 4, 5 cells. On the display top, the input voltage is 24.06 volts, 1.0 watt hours. Channel 1 output is 19.95 volts at 2.02 amps. The charger has been operating for 1 minute 41 seconds, and the cumulative current provided to the battery pack is 67 milliamp hours. The internal temperature is 45.5 degrees, and you can hear the fan has started. This is good. I'm confident this charger will restore all the 5 cells to healthy balance. Now to let this charging process continue, and we will see how long it takes. The total time it took to charge the battery was 7 hours 24 minutes. I took many high-resolution photos of the charger display throughout the charging period. So instead of boring you with over 7 hours of video, I will show the photos and how the charging progressed. I have put all these charging status values into an Excel document and created 2 graphs to show the voltages, current charge capacity, and time taken. Continue with this video to see these 2 graphs shortly. This is where the status of the charger changed from fast charge done to charge done status. It's now doing trickle charging, so I will stop the charging. Press OK, scroll down to stop, press stop. So this is the Excel spreadsheet that I created to capture the charging status of the ToolKit M6DAC balance charger when charging the M18 12mAh battery. I have date, I have the photo ID from my Canon 5D3 camera, I have the timer display values which are originally in minutes and seconds, which I've converted to hours, minutes, seconds. I've recorded the cumulative mAh charge, I've recorded the channel 1 charge voltage and current supply, and in these columns I have the voltages of the 5 cells S1, S2, S3, S4 and S5. I also recorded the status of the charger. So at time 0, before I have started charging, cumulative charge supply is obviously 0, and these are the voltages of the 5 cells when the charger is in standby. The voltage of channel 1 output is 19.43 volts, 0 amps are supplied, and once I've activated charging to start, at time 4 minutes 40 seconds, 0.144 amp hours of charge has been supplied, and these are the voltages of the 5 cells, and the status displayed is lithium-ion 5S charging. And as time progresses, after 3 hours 21 minutes and 01 seconds, the total charge supplied is 3.183 amp hours, and the voltages of the 5 cells have increased, and the display says it is in fast charge done. Note that the first stage charging stopped after 200 minutes elapsed time owing to the security time setting applied to the charger. So I had to restart charging for another 300 minutes, and I recorded that the total capacity after first stage of 200 minutes of charging was 3.17 amp hours. So fast charge continued up to 7 hours 10 minutes 15 seconds later, and the cumulative charge then was 6.51 amp hours, and at time 7 hours 10 minutes 45 seconds the charger displayed status as charge done, and because the charger continued with trickle charge, the cumulative charge increased from 6.51 amp hours through to 6.55 amp hours after time 7 hours 23 minutes 39 seconds. At time 7 hours 24 minutes 50 seconds, I put the charger on standby, and from those values I created this graph, a graph of S1 to S5 cell voltages versus elapsed time charging the M18 12mAh battery. The horizontal axis is hours, minutes and seconds, and note the horizontal time axis is depicted as non-linear. The vertical axis are the voltages of the cells. S1 cell is purple, S2 cell is brown, S3 cell is gray, S4 cell is green, S5 cell is light blue. The charger went through various stages of charging. Initially, the charger is on standby at time 0, and then I activated charging to start, and the display said lithium-ion 5S charging. After about this time, the charger display said fast charge done and continued up to this point in time. After this point in time, the display changed to charge done right up to this point in time, 7 hours 24 minutes 50 seconds, when I put the charger to standby. So S5 has the lowest voltage, starting from 3.666 volts, rose up to 3.695 volt, and then from this point on it increased upwards and stabilized towards the target 4.150 volts. Cell S1 started at 3.78 volts, then it went up to 3.802 and so on. Cell S3 started at 3.853 volts and joined up at about 3.941 volts with cells S5 and S1. And cell S2 started with voltage 3.993 and joined up at this stage. And lastly, cell S4, which has the highest starting voltage of 4.129 volts, kept constant at 4.150 volts. So I noticed the charger holds the voltage of S4 pretty constant, whilst it works on increasing the voltages of the lowest three cells, bringing them up to equality around this point, and continue to increase the voltage until it meets up with the voltage of S2. So it is interesting for me to see how the charging profile works. I created a second graph, and this graph is of the channel 1 output voltage and current versus elapsed time charging the battery. Again, horizontal axis is time in hours, minutes and seconds, where the axis is non-linear, and the vertical axis on this side is the channel 1 output charging voltage, and the vertical axis on the right hand side is the channel 1 output charging current, amps. So the brown line represents the current charge and the blue line represents the channel 1 output voltage. So at time 0, when the charger is on standby, there's 0 amps, and during this stage the charger says it's on lithium-ion 5S charging. The current is the highest, goes up to 1.37 amps, then drops to 1.35 amps, and where the charger status says it's on fast charge done, the current drops, and then where the charger says the status is charge done, I can see that the current pretty much stabilizes and drops to 0 when I put the charger to standby. Whilst the charge current is being supplied to the battery, the output channel 1 voltage rises from 19.43 volts up and reaches around this maximum of 20.84 volts. Then when the charger status says charge done, the voltage pretty much stabilizes to 20.79 volts, and when I put the charger to standby, the voltage drops to 20.75 volts, which is the target voltage I set. So again, this for me is an interesting way to visualize the charging profile carried out by this M6DAC battery charger. I love it. With regards to the balance cable I made, which uses these insulated spade terminals, I made this to suit my own needs and I accept the risk. And in connecting to the MILWAUKEE battery pack like this, I'm taking a risk. I'm making my own risk assessment and not recommending this as a solution for anybody else. It is just for me. Now I want to show how to get into the system settings for this charger. To do that, apply a long press on the scroll wheel OK button. And you see the user interface has changed to input settings for the device. For power selection, it's on automatic. I suspect that if I had a DC power supply input to the XT60 socket at the rear, it will give me the alternative to select battery power input supply as well. Power type. It's automatically set adapter because it comes from the AC mains into the transformer. Maximum power is automatically set 200 because the maximum power output of the internal transformer is 200 watts. Similarly, maximum current for that transformer is 8.4 amps. The voltage range is 22 to 26 volts. Security settings, press OK. And I think the word here, security settings, is not appropriate. It would be better named safety settings because it's about setting the safe internal temperature, the safe external temperature, the safe operation time, and the safe capacity to charge. If I scroll to safe internal temperature, it's on 70 degrees because I changed it to 70. If I press OK on that, it turns red. Scroll left, reduces the value. Scroll right, increases the value. I'll move it back to 70. Same thing, safe external temperature. Press OK, it turns red. You can't scroll left because 40 is the minimum value, except you can scroll up to 80 degrees Celsius. That's too high. So I'll scroll back to 40 degrees, safe external temperature. Save time. It was default on 200. I've changed it to 300 minutes. I'll change it from 300 minutes, which I set, to off. No save time. Scroll down, save capacity, press OK. I can reduce the capacity to 1 mAh or up to 100 mAh or off. Let me just keep that to 20 mAhs. I'm not using synchronous mode. Press OK if I want to turn it on or off. I want to keep it on off. Continuous work, it's on. I can turn it to off. What that does is it remembers the charging parameters I've used and uses that for the next battery. Work completed means that at the end of the charge cycle, what would I like the charger to do? At the moment it says end, which is just stop charging. Press OK and I can go to trickle or back to end. I'll keep it on end. Balance start voltage is on always. If I scroll right, nothing happens. Scroll left, it drops to negative 500 millivolts, negative 400 millivolts, negative 300 millivolts, negative 200 millivolts, negative 100 millivolts. That's the lowest. I actually don't know what this means, but I'll keep it on always, which was the default. Battery selection is on off. If I press OK, if the battery selection is on, it keeps in memory the various battery type profiles that I've charged on this device. I'll keep it on off. Backlight is on 10, press OK, and 10 is the highest. If I scroll left, you'll see the backlight diminishes. So I'll keep it on 10. Buzzer is on 6. It can be set on off or 1 up to 7 the maximum. I'll keep it on 6. Language, English. If I scroll right, Deutsch, French, Italian, Portuguese, Espanol, Chinese, and several other languages. I'll scroll it back to English and press OK. Theme style, there are 2 choices. Dark theme, which is what I'm using now, or if I press OK, scroll to light. Because I was taking video and photographs of the display screen, it was better that I kept it on the dark theme. I can press default to return all the settings back to default, and that is the firmware version 1.08. Press exit to go back up, and that's it, it's safe. If instead of using AC mains power supply, I wanted to use a battery, I can do that with this twin core DC power cable that I made. On this end, it has the XT60 connector to plug into the rear DC power in XT60 socket, and at this end, it has an Anderson SB50 connector, which allows me to connect to my external battery, which I've also terminated with a similar Anderson SB50 connector. In the video description below, you'll see a link to how I made this cable. In summary, I'm glad I bought this ToolKitRC M6DAC balance charger, and as you can see from my using it to charge this MILWAUKEE M18 12mAh battery, it is so easy to use, it is so precise, and allows me a lot of control over the charging capability. It would have been very wasteful for me indeed if I had to get rid of this MILWAUKEE M18 battery because of the imbalance and therefore the reduced output capacity of the battery pack. But with this balance charger, I was able to give this battery pack new life, and I'm glad I made this balance cable with the insulated blade terminals, which allow me easy connection to the 6 contacts on the battery pack without soldering. And I have another 2 battery packs like this that are also out of balance and that I can easily rebalance using this charger and charging system. This is my first balance charger, and I think it's a brilliant product. I hope you found this video interesting. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.